In the beginning, there was silence. Not the silence of a quiet room, but the deep and endless hush of a cosmos unformed, a silence so vast it could cradle eternity. Out of that darkness came light, not blazing suns, not galaxies in their glory, but the first frail whispers of photons released into the newborn universe nearly 14 billion years ago. They drift still, across an ocean of time, their journey unbroken, their story unwitnessed, forgotten messengers carrying with them the memory of creation. The universe is not empty, it is filled with this ancient glow, stretched thin by the expansion of space itself. Each photon, once fierce with energy, now cooled to a faint whisper in the microwave sky. This relic light, the cosmic microwave background, is the oldest thing the human eye can ever perceive. A fossil of light, born when the universe was just 380,000 years old, long before the first star ignited. Across this immeasurable canvas, silence reigns not as absence, but as presence. Silence as the pulse of infinity. Between galaxies lies not void, but a cathedral of distance so immense that even light, the fastest traveler known, requires millions of years to cross its aisles. And yet the photons endure, faint, cold, eternal. They remind us that what we see in the night sky is never the present, only the past, stitched together from rays of light that have outlived empires, outlived worlds, outlived everything we call now. This is the great ocean in which existence is suspended, a sea of memory carried by forgotten light. And it is here, in this quiet glow, that the mystery of the cosmos begins. Discovery phase. The middle of the 20th century was an era of instruments and listening, where earlier centuries had built glass lenses to magnify distant stars. This new age turned its ears to the sky. Vast metal dishes rose across deserts and grasslands, not to capture starlight, but to catch whispers in radio frequencies, voices too faint for human ears, yet persistent enough to travel across the gulf of space. Astronomy was no longer confined to the optical window. Invisible regions of the spectrum were opening, each carrying new truths about the cosmos. Where Galileo once lifted a small telescope to glimpse moons circling Jupiter, his 20th century descendants raised giant parabolic antennas toward the heavens, plumbing the unseen. It was a golden age of discovery, a time when the sky seemed less like a ceiling and more like an infinite archive, waiting to be decoded. The rise of the radio. Sky by the 1930s, the first radio emissions from the Milky Way had been detected. By the 1950s, the technology had matured. Telescopes in New Jersey, Cambridge, and Jodrell Bank swept the skies, revealing radio galaxies, pulsars, and quasars, beacons from the farthest reaches of space. Each detection pushed the horizon of human knowledge outward, but hidden within this symphony of signals was something stranger, something unclaimed, a low, persistent glow that no catalogue could explain. At first, it was buried in the noise, mistaken for static, dismissed as interference. But like an echo returning again and again, it refused to vanish. Penzias and Wilson in 1964, two engineers at Bell Telephone Laboratories in Holmdel, New Jersey, set out to perfect a new radio receiver. Arno Penzias and Robert Wilson were not searching for cosmological relics. They wanted clarity for communications, silence in their antenna. Instead, they found a stubborn hiss. The great white horn antenna, 40 feet long, was designed with exquisite precision. It could detect radio waves from Earth's atmosphere and beyond with unprecedented sensitivity. But no matter where they pointed it, at the Milky Way, at the horizon, at empty sky, the hiss persisted, a uniform background signal, unyielding, omnipresent. They hunted it with the diligence of engineers. Could it be New York City, radiating its industrial noise across the countryside? No. Could it be the sun, the moon, or a distant star? No. Could it be the pigeons nesting inside the horn, their droppings clinging stubbornly to the metal? They climbed inside, cleaned the antenna, and gently evicted the birds, but the hiss remained. unwanted, unexplained, yet undeniable. What Penzias and Wilson did not know was that a few miles away at Princeton University, Robert Dicke and his colleagues were searching for this very thing. Dicke had theorized that if the universe began in a hot, dense fireball, what would later be called the Big Bang, then space should still be filled with the cooled remnants of that radiation stretched by cosmic expansion into the microwave band. When news of the persistent hiss reached Princeton, Dicke is said to have turned to his team and remarked, "Well, boys, we've been scooped." Thus, by accident rather than intention, the faint afterglow of creation had been revealed. The cosmic microwave background, radiation older than galaxies, older than stars, a fossil of light born when the universe was only 380,000 years old, a glow beyond galaxies. While the microwave background told of the universe's birth, astronomers, peering deeper into the optical sky, began to see another puzzle. By the mid-20th century, wide-field photographic plates and meticulous surveys of galaxies revealed faint halos of light that seemed to spill beyond the confines of individual galaxies. Clusters of galaxies, bound together by unseen gravity, glimmered, not only with the combined starlight of their members, but with something more diffuse, a mist of photons suspended between them. This intracluster light was dim, fragile, barely above the threshold of detection. Yet, it appeared again and again, no matter the observer or the cluster. Some suspected it was an illusion, an artifact of imperfect plates or scattered starlight from brighter galaxies. Others whispered that it might be the ghosts of stars torn from their homes, stripped away by tidal forces as galaxies collided and merged. If true, then between the great cities of the cosmos lay a graveyard of orphaned suns drifting in the dark. Early excitement, early doubt, the discoveries of this period carried with them both awe and resistance. The cosmic microwave background was soon embraced as the most compelling evidence for the Big Bang, silencing many advocates of the rival steady-state cosmology. But it was not universally celebrated. Some questioned whether the background was truly cosmic, or merely a product of local astrophysical sources. Years of follow-up measurements would be required to prove its universal nature beyond doubt. The intracluster light provoked even more hesitation. It was elusive, difficult to measure, and often contaminated by foreground stars or instrumental glare. Was it real, or was it wishful thinking? If real, was it evidence of vast stellar populations, unaccounted for, or a new window into the violent dynamics of galactic evolution? These uncertainties became fuel for debate. Scientific journals filled with cautious reports, skeptical commentaries, and careful rebuttals. Each faint photon demanded rigorous defense, and yet beneath the skepticism there lingered an excitement, the sense that the universe was offering up secrets stranger than anticipated, the human dimension. In those years, astronomy was still a discipline of patience and craft. Photographic plates had to be exposed under dark skies, developed by hand, and examined under magnifying lenses. Radio telescopes required teams of engineers and long hours of calibration. Errors could masquerade as discoveries, and discoveries could be dismissed as errors. Against this backdrop, the persistence of unexplained glows, both in radio microwaves and optical halos, became a quiet drama in the scientific community. There was no sudden epiphany, no singular moment when the mystery was solved. Instead, there was accumulation, doubt, refinement, and the slow, grinding recognition that the cosmos was more luminous in its shadows than anyone had expected, a universe revealed by accident. Perhaps the most humbling truth of this era was that the greatest discoveries came not from direct pursuit, but from the margins, from static mistaken for noise, from smudges at the edge of plates, from artifacts that refused to vanish. The universe, it seemed, was not inclined to reveal itself on command. Instead, it whispered its history in accidents, waiting for listeners patient enough to hear. Penzias and Wilson had been searching for silence and found the memory of creation. Optical astronomers had been charting galaxies and found light adrift between them. Both revealed that the universe was not only grand in its visible structures, but haunted by relics of deeper processes, echoes of birth, and whispers of destruction. Thus, expanding mystery. By the end of the 1960s, astronomy had entered a new phase. The microwave background was being measured with increasing precision, its uniformity mapped across the sky. The intracluster light, though still controversial, was increasingly acknowledged as real, and new instruments promised even more. Larger telescopes, more sensitive detectors, and eventually space-based observatories would strip away the uncertainties of atmosphere and equipment. But in those first decades, the discoveries remained raw, unresolved, alive with tension. Was the faint glow between galaxies a trivial curiosity, or the key to understanding cosmic structure? Was the microwave background a simple relic, or a coded message about the very origin of everything? Science thrives in such thresholds where data is clear enough to provoke, but not yet clear enough to settle. In that balance between doubt and revelation, wonder flourishes. Legacy of the first glow. The story of the discovery phase is not merely about photons and instruments, but about the human capacity to listen for the unexpected. It is about the willingness to chase a noise that will not go away, to study a glow that may not exist, to linger on anomalies long after others have dismissed them. From this persistence emerged the recognition that the universe is filled with faint, ancient light that carries memory, light that defies silence. And so the golden age of mid-20th century astronomy became more than a chapter in the history of science. It became a mirror to human curiosity itself, fragile, skeptical, yet unwilling to look away from the faintest glimmers of truth. The discoveries of Penzias and Wilson, of galaxy counters and cluster mappers, stand as reminders that the cosmos does not yield its secrets all at once. It reveals them in whispers, in fragments, in radiance barely above silence. And from those whispers began the modern understanding of a universe alive with hidden light. Scientific shock, the discovery was not greeted with triumph alone. It arrived as disturbance, as contradiction, a reminder that the universe rarely offers neat confirmations, but instead unsettles the patterns that human thought tries to impose. For centuries, light had been synonymous with stars. Photons were children of burning cores, the byproducts of nuclear furnaces embedded in galaxies. Light was fire, and fire was order. But in the mid-20th century, astronomers began to measure light that seemed to belong to no star, no galaxy, no familiar structure. It existed everywhere, diffused across the cosmic stage like a forgotten afterimage. This glow carried with it a quiet but profound challenge. Light without stars, a violation of expectation. The cosmological models of the time, built on the foundation of general relativity and the observed distribution of galaxies, predicted a universe that was orderly, structured by gravity, and luminous only where matter coalesced into stars. Between galaxies there should have been darkness, pierced only by faint arcs of scattered starlight. Yet the observations told another story. The sky revealed an excess of faint photons, a cosmic background of diffuse light that could not be easily attributed to known galaxies. This was not the smooth microwave whisper of the Big Bang, but an optical and infrared shimmer, as though the universe itself were bleeding light into the void. To many physicists, this seemed to violate the most basic principle of structure formation. Stars formed in galaxies, galaxies formed in clusters. There was no theoretical room for a great reservoir of orphaned radiance. And yet, the measurements pressed insistently. Something more was out there, something unaccounted for. The early skepticism astronomers are cautious by necessity, for the night sky is treacherous, Every observation is filtered through atmosphere, through mirrors and emulsions, through electronic detectors that are themselves imperfect. A faint smudge of light can be the trace of a cosmic revelation, or it can be dust on a photographic plate, and so the first reports of diffuse intergalactic glow were met with suspicion. Perhaps critics suggested this was merely air glow, the faint emission of Earth's own atmosphere contaminating the measurements. Perhaps it was zodiacal light, sunlight scattered by interplanetary dust within our solar system, masquerading as cosmic in origin. Perhaps it was nothing more than stray reflections within the telescope, or electronic noise imitating a signal. Arguments filled the journals. For every astronomer who claimed to detect faint halos around galaxy clusters, another countered that the evidence dissolved under stricter scrutiny. The debate hardened into camps, those who believed the light was real, and those who believed it was a mirage. The stakes were high. If the glow were genuine, it demanded new physics, or at least new astrophysics processes that no existing theory had yet anticipated. Dust and deception dust became the favored culprit. Interstellar dust, it was known, could scatter starlight and produce faint glows. Interplanetary dust could do the same within the solar system. Dust was everywhere, and dust was deceptive. Whole careers were spent modeling its effects, subtracting its contribution, recalibrating instruments in hopes of stripping away the veil and exposing the true cosmic signal beneath. For every faint excess that survived this subtraction, skepticism redoubled. Was the subtraction itself flawed? Was the glow not cosmic, but a trick of dust's invisible hand? Yet dust could not explain everything. Certain excesses remained stubborn, too isotropic, too evenly distributed to be accounted for by locally scattering. Some of the light seemed to arrive from regions where dust was sparse. The more carefully astronomers tried to erase it, the more insistently it returned. Instruments under trial, if not dust, then perhaps the instruments themselves were guilty. The history of science is littered with false discoveries born from calibration, errors from sensitive devices picking up the unintended. Engineers and theorists alike demanded to know, could the faint glow be nothing more than instrumental flaw? Detectors were rebuilt, antennas recalibrated, telescopes redesigned with baffling to reduce stray reflections. Observatories compared results across continents, and still the background glow refused to vanish. Different instruments, different sites, different methods, and yet the same stubborn signature emerged. It was not uniform. It varied across wavelengths, across observational windows, but it was there, undeniable enough to resist dismissal. The debate grew philosophical. Was it better to assume the cosmos held secrets that our theories could not yet explain, or was it wiser to assume error until every possibility of contamination had been eliminated? Galaxies come up. Short by the late 20th century, galaxy surveys had advanced to the point where astronomers could attempt a census of light. If every galaxy in the observable universe were counted, their starlight measured, and their cumulative contribution estimated, could this sum account for the diffuse glow? The answer was unsettling. Even under the most generous assumptions, galaxies could not produce enough light. The universe seemed to shine brighter than the sum of its parts. It was as though every lamp in a great cathedral had been carefully counted, and yet the hall still glowed more brightly than the lamps could explain. Somewhere, hidden sources of light were at work. This realization deepened the mystery, for it suggested that the excess was not an illusion, but a genuine feature of the cosmos. And if galaxies were insufficient, then something stranger must be the source. Forgotten light, it was in this crucible of doubt and contradiction that the mystery gained its first true identity. Astronomers began to speak of a diffuse cosmic background light, distinct from the microwave relic of the Big Bang. This was light that had slipped through the cracks of history, light untethered from familiar sources. Some called it the cosmic optical background. Others referred to it as extragalactic background light. But more evocative terms spread in the community: lost light, orphan light, and most haunting of all, forgotten light. The phrase captured both the scientific and the poetic essence of the mystery. These were photons that had escaped the galaxies. That should have contained them. Photons scattered across intergalactic space, photons adrift for billions of years. They were relics, not of a single moment like the cosmic microwave background, but of countless forgotten processes, stars shredded by tidal forces, galaxies colliding, supernovae flinging their radiance into the dark. Forgotten, not because they never existed, but because they came from stories the universe no longer remembers. Shockwaves in physics. For physics, the implications were unsettling. If significant fractions of light could exist beyond galaxies, then the models of cosmic structure required revision. Gravity alone, acting on baryonic matter, might not suffice to explain the distribution of light. Additional processes, mergers, disruptions, unseen populations of faint galaxies had to be invoked. Worse still, the excess threatened to upset delicate cosmological balances. The energy density of the universe, the rate of expansion, the role of dark matter all depended on careful bookkeeping of matter and radiation. If vast oceans of light had been overlooked, then the books had to be rewritten. It was not merely an observational puzzle. It was a challenge to the architecture of the universe itself. The culture of doubt, the shock was not expressed in headlines, but in the quieter language of academic caution. Papers spoke of discrepancies, of excesses, of possible systematic errors. Conferences buzzed with whispered debates, arguments sharpened by skepticism. For decades, the scientific culture remained wary of embracing the forgotten light too fully. Yet, beneath the caution, wonder lingered. What if the glow was not error, but truth? What if intergalactic space was not dark, but luminous with scattered memory? What if the universe itself was brighter than human eyes had dared to believe? New kind of background. By the turn of the 21st century, the existence of the cosmic optical background was increasingly acknowledged. Satellites, free from the interference of Earth's atmosphere, confirmed the glow at multiple wavelengths. The data was still imperfect, the contamination still difficult to subtract, but the persistence of the signal was undeniable. This was not a smooth, isotropic relic like the microwave background. It was structured, messy, layered with the complexities of cosmic history. It was not the single voice of creation, but a chorus of forgotten song. The scientific shock gave way to a broader recognition. This background was not a nuisance, not contamination. It was a window, a way of glimpsing processes otherwise invisible, the tearing of stars, the faintest galaxies beyond current detection, the slow erosion of structure across cosmic time. Forgotten light was no longer an embarrassment to theory. It was an invitation to new theory. A universe haunted by light. In retrospect, the shock of forgotten light can be seen as part of a broader theme in science. The universe is always more than it appears. Just as dark matter revealed invisible mass, and dark energy revealed invisible forces, so too did forgotten light reveal invisible radiance. The cosmos is not a tidy ledger, but a haunted archive filled with remnants that refuse to vanish. And yet, forgotten light carries a distinct poignancy. It is not wholly alien like dark matter or dark energy. It is light, familiar in its essence, but estranged in its origin. It is the echo of stars that once burned, the glow of galaxies that once thrived. It is memory rendered luminous. In every forgotten photon lies a history that no longer has a name. And in their collective, the universe speaks a truth. Nothing is ever fully lost. Legacy of the shock. The scientific shock of forgotten light has not ended. Even today, debates continue about its precise origins, its true magnitude, its implications for cosmic evolution. Instruments grow more sensitive, models grow more sophisticated, and yet the glow persists, refusing to yield all its secrets. But the shock itself, the recognition that the cosmos contains more light than galaxies alone, can produce remains one of the quiet turning points of modern cosmology. It is a reminder that the universe is not only vast, but deeply mysterious, capable of overturning expectation even in the most familiar of domains. Forgotten light stands as both puzzle and poetry, a scientific anomaly that unsettled the order of physics, and a luminous metaphor for memory, for persistence, for the refusal of history to be erased. And in this shock, astronomy learned once again that the night sky is not what it seems. It is brighter, stranger, and infinitely more haunted. Deeper investigation. The scientific shock of forgotten light did not fade. It deepened. What began as anomaly became a frontier, a riddle to which every new telescope turned its gaze. If light existed where no stars should be, then instruments must sharpen, theories must bend, and the quiet glow of intergalactic space must be pursued with the patience of centuries. This pursuit would unfold not through a single revelation, but through a series of advances, each telescope, each survey, each wavelength peeling away layers of deception. What emerged was not resolution, but a growing sense that the mystery itself was larger than anyone had imagined. The eyes that could see the invisible. The late 20th and early 21st centuries brought forth a new generation of space. Telescopes, machines designed not to pierce atmosphere, but to rise above it. Freed from Earth's veil, they could see the cosmos as it truly is, unblurred, unfiltered, uncompromised. Hubble, the archivist of starlight. Launched in 1990, the Hubble Space Telescope became humanity's archivist of visible light. With clarity unmatched, it revealed galaxies in astonishing detail, each spiral arm etched against the dark. But Hubble also became a chronicler of faintness. Its deep fields exposures that gazed at a single patch of sky for days at a time uncovered galaxies so distant and dim they would have been invisible from Earth. And yet, even when galaxies were accounted for, Hubble revealed something more. Around clusters of galaxies, diffuse halos of faint light, appeared structures too soft to belong to any one galaxy, too spread to be dismissed as glare. The deeper Hubble looked, the more it saw these ghostly glows, evidence that space between galaxies was not as dark as once thought. Chandra, the universe in X-rays. Where Hubble revealed optical brilliance, Chandra, launched in 1999, showed the cosmos in X-rays. Galaxy clusters blazed in high-energy light, their intracluster gas heated to millions of degrees. This gas, bound by gravity, acted as both clue and context. For if galaxies were colliding, if stars were being stripped, then the gas compressed, and shocked bore witness. Chandra traced the skeletons of cluster mergers, the hidden violence that could explain how stars might be flung adrift into intergalactic space. Spitzer, the glow of the infrared light, invisible to the eye, carries the warmth of dust and faint galaxies. The Spitzer Space Telescope, launched in 2003, unveiled a cosmos awash in infrared glow. Here, the mystery grew deeper still. The infrared background appeared brighter than expected, even after known galaxies were tallied. Spitzer suggested that hidden populations, ultra-faint galaxies, dwarf systems, or even the shredded remains of ancient stellar nurseries might be contributing to the forgotten light. But the subtraction was painstaking, the uncertainty immense. Dust, zodiacal light, and instrumental noise clung like fog to every measurement. And yet, even after layers of correction, the excess glow endured. Galaxies, the ultraviolet frontier. In 2003, the Galaxy Evolution Explorer, Galaxies, opened the ultraviolet window. Ultraviolet light reveals young, hot stars, tracing recent star formation. In clusters and in faint galactic outskirts, Galaxies mapped bridges and tails of ultraviolet emission, signatures of stars born or torn loose during collisions. Each filament suggested violence on a cosmic scale, galaxies stripping stars from one another like sparks flung from colliding embers. Together, Hubble, Chandra, Spitzer, and Galaxies became a quartet of vision optical, X-ray, infrared, ultraviolet. Each saw differently, each confirmed in its own way that the cosmos glowed in places galaxies could not fully explain. Separating the known from the unknown, the pursuit of forgotten light demanded extraordinary rigor, for the cosmos is filled with sources of deception, and the glow in question was faint, a whisper in a storm. Astronomers devised methods of subtraction. Galaxies were masked out of images pixel by pixel, their light modeled and removed. Foreground. Stars were meticulously catalogued and excluded. Dust maps were constructed, tracing contamination across the Milky Way. Even sunlight scattered by the thin veil of interplanetary dust, zodiacal light, had to be simulated and stripped away. What remained after this painstaking process was a residual glow, weak, fragile, yet persistent. The harder astronomers tried to erase it, the more convinced they became that it was real. It was not the product of instruments or dust alone. It belonged to the universe itself. Intracluster light, stars without. Homes. The most compelling evidence pointed to intracluster light stars stripped from galaxies and left adrift in the gravity wells of galaxy clusters. Galaxies are not islands. They collide, merge, and cannibalize one another. In these encounters, gravitational tides stretch and tear, flinging stars into intergalactic space. Some remain bound to clusters, orbiting invisibly in halos, too diffuse to belong to any single galaxy. These stars, scattered like ashes, form a population of the homeless, luminous yet unanchored. Hubble's deep imaging revealed arcs and streams of such stars, delicate filaments stretching between colliding galaxies. In the Virgo cluster, in the Coma cluster, in countless others, astronomers traced faint bridges of light. They were cosmic scars, remnants of encounters that had unfolded over billions of years. Chandra's X-ray maps showed that these same regions were filled with hot gas, further evidence of violent mergers. Galaxy's ultraviolet vision showed young stars still forming in these tidal streams. The picture was clear. The universe was not a static order, but a restless battlefield, scattering light into the void, and yet intracluster light explained only part of the excess. The glow extended beyond clusters, beyond the reach of tidal debris. More sources had to exist. Cosmic dust, not just in the Milky Way, but dust across cosmic history, could scatter starlight and produce diffuse glows. Cosmic dust drifting between galaxies was considered a potential culprit, but models suggested it could not produce enough light, nor explain the distribution observed. Ultra-faint galaxies. Perhaps the glow came not from stars stripped away, but from galaxies too faint to detect. Tiny dwarf star clusters at the edge of visibility, populations missed even by Hubble's deep fields. If countless faint galaxies dotted the cosmic web, their combined radiance might account for the missing light, but surveys struggled to reconcile the numbers. Even with generous estimates, the faintest galaxies could not fully explain the excess. Scattering effects. Some speculated that exotic scattering processes, perhaps involving intergalactic medium or even physics beyond the standard model, could redirect photons and mimic a background glow. These ideas remained speculative, tantalizing but unproven. In every explanation, uncertainties grew. For every possibility ruled out, another arose. The glow seemed determined to resist simple answers. Mapping the bridges of light, the 21st century brought a new kind of cartography. The mapping of cosmic structures not only by mass or by galaxies, but by light itself, Hubble and ground-based. Surveys traced delicate bridges of stars stretching between galaxies mid-collision. Some of these bridges spanned hundreds of thousands of light-years, great rivers of light flowing into intergalactic space. In the Fornax cluster, a vast stream of stars linked galaxies like threads of silk torn loose. In the Coma cluster, halos of intracluster light spread like mist around galactic giants. These were not isolated oddities, but common features, evidence that forgotten light was woven into the very fabric of cosmic evolution. The light was no longer background. It was structure. It was history made visible. More questions than answers, yet with every new discovery, the puzzle deepened. Intracluster light explained some, but not all. Ultra-faint galaxies filled gaps, but not enough. Dust played a role, but too small. Scattering processes lingered on the edge of speculation, and so the mystery endured. The more telescopes revealed, the more elusive the full answer became. The forgotten light was no longer dismissed as error. It had become an enigma woven into the cosmos, undeniable, measurable, and yet unresolved. Each advance raised further questions. How many stars truly live outside galaxies, and how many were lost to mergers long ago? Could entire populations of galaxies still hide beneath the threshold of detection? What role does forgotten light play in the balance of cosmic energy, in the unfolding of structure, in the destiny of the universe itself? The forgotten light, once considered an inconvenience, had become a frontier, a cosmos that refuses simplicity. The deeper the investigation went, the clearer the lesson became. The universe is not simple. It is not a clean ledger where every photon can be tallied, every process accounted for. It is a restless theater, scattering light, erasing history, leaving traces that confuse even the most careful observers. Hubble, Chandra, Spitzer, Galaxies. Each added detail, each confirmed the existence of light unbound to galaxies, and yet none could complete the story. Forgotten light was not a single phenomenon. It was many. Stars stripped by tides, galaxies too faint to count, dust scattering in silence, photons wandering paths unpredicted. Together, these fragments wove a mystery larger than its parts. In this way, the deeper investigation did not solve the riddle. It magnified it. The unfinished story. Today, the forgotten light is recognized as one of the great unsolved puzzles of cosmology. It has moved beyond the margins of debate and into the core of investigation. Future telescopes, the James Webb Space Telescope, the Nancy Grace Roman Space Telescope, the Vera Rubin Observatory are tasked with peeling back its layers. They will count the faintest galaxies, trace the faintest streams, and push further into the darkness where the glow persists. But the lesson of history lingers. With each step deeper, the cosmos grows stranger still. Forgotten light is not anomaly, but testimony that the universe is more luminous, more violent, and more complex than any model can yet contain. Every photon, every bridge of stars, every faint glow in the void is a reminder that the story of light is also the story of. It is the record of creation and destruction, of galaxies colliding and stars unbound. And though astronomers have named it, mapped it, and debated it, the forgotten light remains exactly what its name suggests. A memory half erased, a riddle not yet solved, a glow that deepens the mystery the closer we approach. Escalation. Mystery deepens. The mystery did not fade with time. It grew heavier, stranger, more insistent. For what began as faint excesses in background light anomalies at the edges of observation began to reveal a pattern. As data from Hubble, Spitzer, Galaxies, Chandra, and their terrestrial counterparts accumulated, the evidence sharpened into something undeniable. The universe was brighter than its galaxies. It was a statement that should have been absurd, a contradiction written into the sky itself. For galaxies, the luminous islands of stars and dust were meant to be the engines of all light. To suggest otherwise was to suggest that half the story of cosmic illumination was missing. Yet, by the turn of the century, the measurements spoke. In unison, the glow of forgotten light was roughly twice what galaxies alone could produce, twice the light. The cosmic optical background, when compared to the census of galaxies, consistently yielded an imbalance. Galaxies explained perhaps half of the measured glow. The remainder, vast oceans of photons, resisted categorization. Spitzer's deep infrared maps revealed fluctuations in brightness that no population of visible galaxies could explain. Hubble's deep fields, though rich with thousands of galaxies, still left deficits in the balance sheet of light. Ground-based surveys of galaxy clusters confirmed intracluster stars, but even they could not close the gap. It was as though every lamp in the cathedral of the cosmos had been counted, and still the walls glowed brighter than the lamps could allow. The implication was unavoidable. Either galaxies were not the sole architects of light, or astronomers had misunderstood the very nature of cosmic radiance. Light, older than galaxies, the enigma deepened further with the suggestion that some of this light might be older than the galaxies themselves. Fluctuation analyses in the infrared hinted at photons that appeared to originate from an epoch before fully formed galaxies emerged. If true, then the glow carried memory of the universe's first structures, populations of stars born in the cosmic dawn, in the era when the first hydrogen clouds collapsed into flame. These primordial stars, vast and short-lived, could have flooded the young cosmos with radiation, much of which would now be stretched and diffused into the background glow. The possibility was staggering that embedded within the forgotten light was a record of epochs no telescope had yet resolved, a fossil imprint of the first fires that ever burned. Light not just orphaned by collisions, but light older than galaxies themselves, still wandering the intergalactic dark, engines of orphan starlight. Yet not all the forgotten light traced to ancient origins. Much of it appeared to be generated by collisions on scales vast and violent. Galaxies are restless travelers, drawn together by the invisible threads of gravity. When they meet, they do not pass quietly. Their stars, though tiny compared to the gulf of space, feel tidal forces that stretch and tear. Bridges of stars are flung outward, tidal tails curl into arcs, and in the aftermath of mergers, whole populations of suns find themselves expelled into the void. These events were no longer speculation. Hubble revealed them in exquisite detail. The antennae galaxies, the tadpole galaxy, the chaotic knots of merging clusters. Chandra traced the accompanying shocks of gas. Galaxies found new stars kindled in the debris. In each case, light was released into the intergalactic medium, no longer bound to a host. Collisions, it seemed, were engines of orphan starlight scattering luminous matter into the spaces between galaxies, building the diffuse halos and faint bridges now seen across the sky. If such processes had been common throughout cosmic history, the implications were profound. For every merger, for every shredded spiral, countless stars might have been cast adrift. Their collective radiance, accumulated over billions of years, could account for a vast portion of the forgotten light. Yet still, not all. Models in crisis, the persistence of this glow pressed against the boundaries of cosmological models. For decades, astronomers had built models of star formation, estimating how much gas should condense into stars, how much light those stars should release, how galaxies should evolve. These models matched observation with satisfying precision until the forgotten light refused to fit. If half the universe's radiance was missing from the models, then perhaps the star formation history of the cosmos was incomplete. Perhaps stars had formed in hidden populations of faint galaxies, or in structures too diffuse to catalogue. Perhaps the tally of cosmic starlight had always been underestimated. Such a possibility was more than unsettling. It meant that the history of the universe, its timeline of creation, its evolution into structure was not fully known, that the very scaffolding of cosmology rested on incomplete accounts. Growing tension. As the evidence mounted, so too did the tension. The forgotten light was no longer dismissed as error, no longer whispered about in footnotes. It was real. It was measurable, it was stubborn. If galaxies alone could not explain it, then the models of cosmic structure needed rewriting. If some of it originated before galaxies themselves, then the timeline of star formation demanded revision. And if collisions were scattering light into intergalactic space, then the universe was far more wasteful, far more chaotic than once imagined. This was more than a question of photons, it was a question of history. For in this glow, dim and persistent, might lie the secret of the cosmos itself, a record of its first stars, of its most violent mergers, of its hidden population, a history not told in galaxies, but in the forgotten radiance that lingers between them, a mirror of the unknown. The deeper astronomers searched, the clearer it became that the forgotten light was not anomaly, but revelation. It was a mirror reflecting back the incompleteness of human knowledge. It was evidence that the universe has not yielded all its secrets, that its history is scattered in fragments across the dark. Twice the light, older than galaxies, bridges across clusters, glows that defy dust, instruments, and subtraction. Each fact confirmed, and yet each fact deepened the mystery. The forgotten light had become not only a puzzle of astrophysics, but a philosophical weight. It suggested that memory itself, cosmic memory, is never perfect. That history, even on scales of galaxies and stars, leaves traces that resist reconstruction. Toward the edge of understanding, in conferences and journals, the tension sharpened. Was the forgotten light primarily intracluster stars, hidden galaxies, primordial radiation from the first epoch of star formation, some combination of all three? Or was it something even stranger, a signature of processes not yet imagined? No consensus emerged, only the agreement that the glow was real and that it mattered. What had begun as background noise had become foreground mystery. Forgotten light was no longer a footnote in cosmology, but a central challenge, the secret in the glow, and so the mystery deepened. The forgotten light was not simply excess brightness, it was a clue that the story of cosmic star formation had been told, incompletely, that galaxies were not the whole stage of history, that stars lived and died, were torn and scattered in ways more dramatic than theory had foreseen. The glow was a secret, written not in the brilliance of galaxies, but in the faint radiance between them. It was the signature of everything the universe had tried to forget and failed. For every orphaned star, every shredded galaxy, every primordial fire had left its mark. Together they formed a background glow that refuses silence. If astronomers can decode it, they may uncover not only the hidden history of light, but the hidden history of the universe itself. Theories and speculations, the forgotten light once dismissed as error, now stands as one of the most haunting riddles in modern cosmology. It is measured, confirmed, undeniable. And yet, its origin remains hidden, a cosmic confession written in half-erased ink. To explain this radiance, astronomers and physicists have offered theories as varied as the universe itself, some grounded in the known, others daring toward the speculative. Each is incomplete, each carries both strength and shadow, and each in its own way reflects the human need to make sense of mystery. Orphan stars. The most tangible explanation is also the most human, that the light comes from stars once bound, now abandoned. The story galaxies are not eternal fortresses. They collide, merge, and devour. In these encounters, gravitational tides tear at their edges, flinging stars outward into intergalactic space. These stars drift free, unattached, shining alone in the cold between galaxies. Astronomers call them intracluster stars or orphan stars. Their existence is no longer in doubt. Observations from Hubble and deep field surveys have revealed faint halos of light around clusters, bridges of stars stretched between colliding galaxies, diffuse arcs marking the scars of ancient mergers. Strength's orphan. Stars are real, and they glow. Their light matches at least part of the excess background measured across the sky. They explain why galaxy clusters often appear surrounded by diffuse radiance, why tidal tails shimmer long after collisions end. The mechanism is natural. Galaxies have collided throughout cosmic history, and every such encounter scatters stars into the dark. Over billions of years, the accumulated population of these orphans may form vast seas of intergalactic light. Weaknesses, but can they explain all the forgotten light? Most studies suggest not. Intracluster stars account for perhaps a fraction measurable, but insufficient. Even with generous estimates, the glow exceeds what tidal debris alone can supply. The orphan theory comforts with tangibility, but it leaves gaps unlit. It is a story partly true but incomplete. Emotional resonance, there is a poignancy here. Stars cast out, wandering without galaxies like exiles, carrying their radiance into emptiness. They are luminous ghosts, testimonies to violence and loss. If much of the forgotten light comes from them, then the cosmos itself is built not only on creation, but on dispersal, on the scattering of what was once whole, primordial stars. Where the orphan star theory looks to the near past, another points to the deep beginning. The story, the first stars, population 3 stars, are believed to have formed a few 100 million years after the Big Bang, composed almost entirely of hydrogen and helium. Massive beyond any modern star, they burned hot and lived briefly, seeding the cosmos with the first heavy elements. If these stars flooded the infant universe with light, some of that radiance could remain, stretched by cosmic expansion into faint infrared glow. The forgotten light may thus be an echo of cosmic dawn, preserved across billions of years. Strengths. This theory explains why part of the glow appears older than known galaxies. Infrared fluctuation analyses suggest contributions from sources predating large-scale galactic structures, exactly where primordial stars should shine. It also carries explanatory power for the rayonization of the universe. The early cosmos transitioned from opaque hydrogen fog to transparency. Primordial stars are thought to have provided the photons that pierced the fog. Forgotten light could be the lingering residue of that transformation. Weaknesses, but direct evidence of population 3 stars remains elusive. No telescope has yet seen them in isolation. Their signatures are inferred, not measured, and while they may explain some portion of the excess light, models suggest they too cannot account for the full magnitude. There is also a timing puzzle. The epoch of first stars was brief, their light diluted by cosmic expansion. Can echoes that faint truly survive so powerfully today? Emotional resonance, the idea that forgotten light is the echo of the first stars, touches a deep chord. It means we are bathed even now in the radiation of beginnings, the luminous breath of the cosmos as it awoke. To gaze into the forgotten glow would then be to glimpse, not exile, but origin. Memory, not of scattering, but of first fire, dark matter, decay. Some theories leap beyond the visible, into the invisible scaffolding of the universe. Dark matter. The story, dark matter outweighs visible matter 5-1. It does not shine, it does not absorb, it does not reveal itself except through gravity. And yet in some theoretical models, dark matter particles are not perfectly stable. Over billions of years, they may decay, releasing photons as byproducts. If true, then the forgotten light might not come from stars at all, but from the invisible halo of dark matter surrounding every galaxy and cluster. It would mean the glow is not a relic of ordinary astrophysics, but of new physics. Strengths. This theory is radical, but not impossible. Particle physics allows for unstable dark matter candidates. Their decay could produce faint, diffuse light. Distributed across the cosmos just as observed, it could explain why the glow is isotropic, appearing across the sky. Dark matter is everywhere. Its decay would produce universal radiance. Weaknesses, but evidence is thin. No direct signature of dark matter decay has been found. Models must finely tune particle lifetimes and energies to match observations. And critics argue that astrophysical sources, stars, dust, faint galaxies remain more likely explanation. Moreover, if dark matter decayed too quickly, cosmic structure would not exist as we see it today. The theory must walk a narrow line, explaining the glow without destroying the universe's architecture. Emotional resonance. If true, this theory rewrites the story of light. It would mean that radiance is not only the child of stars, but of the very invisible matter that shapes the cosmos. That darkness itself glows faintly, secretly. Forgotten light would then be not memory of destruction or creation, but a whisper from the hidden majority of existence. Quantum vacuum energy, some theories dare further still into the strangeness of quantum fields. The story in quantum physics, the vacuum is not empty. It seethes with virtual particles, fluctuations of energy that appear and vanish in fleeting instants. Some speculate that such fluctuations could, in aggregate, produce real photons, faint light emitted not by matter, but by the void itself. To a forgotten light might then be not relic, not orphan, not starborn at all. It could be the glow of existence itself, the universe radiating simply by being. Strength's quantum field theory already predicts vacuum energy, though its magnitude is one of the great unsolved puzzles of physics. If the vacuum produces photons, then a faint background glow would be natural. It would explain why the light is diffuse, unanchored to structures, and persistent across time. Weaknesses, but the theory is speculative. Vacuum fluctuations are real, but whether they can yield observable photons at cosmic scales remains unproven. The energy mismatch between predicted and observed values, the cosmological constant problem, casts deep doubt. Most physicists view this idea as too untested to stand beside astrophysical explanations, and yet it lingers because the void itself remains mysterious. Emotional resonance. If the void glows, then every corner of the cosmos is sacred with radiance. Forgotten light would not be the product of stars or galaxies at all, but the universe's own heartbeat. The dark between galaxies would no longer be absence, but presence. Silence would itself be luminous. The multiverse speculations. At the edge of imagination lies the most audacious speculation. That forgotten light may be a sign, not of this universe, but of others. The story. Some versions of cosmology propose that our universe is not alone, but one of many. The multiverse may contain countless other domains, each with its own physics, its own laws, its own light. If so, photons might bleed across boundaries, leaving faint signatures in our cosmos. The forgotten light could thus be leakage, a whisper, of other universes overlapping with our own. Strengths. There is poetry here, but little empirical grounding. Some theories of inflation and string cosmology allow for multiverses. If real, they might leave observable imprints, though none are yet confirmed. Forgotten light, diffuse and unexplained, tempts the imagination as such an imprint. Weaknesses, but the idea is highly speculative, far beyond current evidence. Most cosmologists regard it as philosophy rather than testable science. Forgotten light has more straightforward astrophysical explanations. Invoking the multiverse risks multiplying mysteries instead of solving them. Emotional resonance, yet the allure remains. If the glow is a whisper from other universes, then we are not only part of a cosmic history, but of a cosmic chorus. Forgotten light would be the hymn of existence itself, sung across realities. To contemplate it is to confront the possibility that the boundaries of our universe are not the boundaries of all that is, a tapestry of possibilities. None of these theories alone suffices. Each explains part of the glow. None explains it all. Orphan stars account for some, but not the excess. Primordial stars may contribute, but their signatures remain faint. Dark matter. Decay is bold, but speculative. Quantum vacuum energy is profound, but untested. The multiverse is poetic, but unproven. Perhaps the truth is a tapestry, a weave of orphans, primordial echoes, faint galaxies, dust and processes yet unknown. Perhaps forgotten light is not a single phenomenon, but the sum of many, our human reflection. What makes this mystery endure is not only its physics, but its resonance with human longing. Forgotten light is the memory of stars exiled, the echo of first fires, the whisper of hidden matter, the possibility of glowing voids, the poetry of other universes. It is a reminder that science is not only measurement, but meaning, that in Searching for the origin of photons, we also search for our own place in the cosmos. For if the universe itself cannot account for its own light, then how much more are our own histories incomplete, our own memories fragile? Forgotten light is both riddle and mirror. It unsettles theory, and it unsettles us, because it shows that even the most familiar of things, light itself, may carry secrets too vast for certainty. Closing reflection. The theories and speculations are not answers, but invitations. They point not to resolution, but to the depth of the unknown. They remind us that the cosmos is larger, stranger, and more luminous than models can contain. The forgotten light remains, orphaned, primordial, hidden, exotic, or perhaps all at once. It shines not only as a puzzle of physics, but as a symbol of mystery itself. For in the end, what matters is not that the glow is explained, but that it is seen. That in the faint radiance between galaxies, humanity has found a question worthy of wonder. Scientific tools and ongoing testing, the forgotten light lingers like a rumor the cosmos refuses to silence. It has been glimpsed, measured, debated, but never fully explained. And so astronomers turn not only to speculation, but to sharper tools. For if the glow is real, if it truly doubles the radiance of galaxies, then it demands instruments equal to its mystery. The story of the next decade is not merely one of ideas, but of machines, telescopes so precise they can strip light from noise, surveys so vast they can chart stars in exile, and missions so ambitious they may finally decide whether forgotten light is a trick of perception or a truth of the universe. James Webb, the watcher of first light, the James Webb Space Telescope, launched in 2021, is often described as Hubble's successor, but in truth it is something stranger, a time machine. Its great gold mirrors, unfolding like the petals of a mechanical flower, were designed to capture faint infrared light stretched across billions of years. For the puzzle of forgotten light, Webb is both savior and tormentor. On one hand, it has the sensitivity to detect galaxies so faint they previously escaped the census. On the other, it has revealed that even when galaxies are counted in exquisite detail, excess light remains. Webb's deep fields glitter with thousands of galaxies, many seen as they existed in the first few 100 million years after the Big Bang. Yet, even with this unprecedented vision, the background glow measured between galaxies still exceeds expectation. Webb, it seems, has not closed the case, but sharpened it. It is the detective who lifts the lantern higher, only to reveal more footprints leading deeper into the dark. Euclid, the cartographer of the cosmic web. If Webb is the archaeologist of ancient starlight, the European Space Agency's Euclid mission is the cartographer of cosmic structure. Launched in 2023, Euclid surveys billions of galaxies across 1/3 of the sky, mapping the cosmic web with precision unprecedented. For the enigma of forgotten light, Euclid offers two gifts: scale and lensing. By capturing vast numbers of galaxies, it improves the census of cosmic light. And by analyzing the subtle distortions of gravitational lensing, the bending of light by unseen mass Euclid probes the invisible scaffolding of dark matter, which may itself play a role in scattering or even producing photons. Euclid cannot match Webb's depth, but it sees breadth, the great tapestry of cosmic evolution. If hidden populations of faint galaxies contribute to the glow, Euclid may reveal their fingerprints in the statistics of its maps. The Roman Space Telescope, the wide-eyed hunter NASA's Nancy Grace Roman Space Telescope, scheduled for launch later this decade, will combine the wide vision of Euclid with the sensitivity of Hubble. Its vast field of view will allow it to conduct wide-area deep surveys, capturing both faint galaxies and the diffuse glow that surrounds them. Roman's coronagraph, designed to block the glare of stars, will also aid in detecting faint signals. If orphan stars drift in halos too subtle for other instruments, Roman may catch their radiance. If the glow arises from unresolved galaxies, Roman's surveys may finally bring them into the fold. Together, Webb, Euclid, and Roman form a triumvirate: deep, wide, and sharp. If any instruments are capable of taming the mystery of forgotten light, it is these, the art of detecting diffuse light. The challenge, however, is not only to look, but to subtract. Forgotten light hides beneath layers of contamination, zodiacal, light from dust in the solar system, air glow from Earth, scattered starlight from galaxies, electronic noise from instruments. Detecting the true cosmic glow is less like photographing a landscape and more like excavating a fossil buried beneath countless sediments. Astronomers mask galaxies pixel by pixel, model their light, subtract it, and examine the residual. They map the foreground dust of the Milky Way, then remove it. They simulate the brightness of zodiacal dust, then filter it out. Every subtraction risks error too much, and real signal is erased. Too little, and false glow remain. The process requires humility, for the danger of self-deception is immense. Forgotten light has survived decades of skepticism precisely because it resists these subtractions. It endures, faint but insistent, like static on a radio that no amount of tuning can silence. Ground-based surveys, the long patient space telescopes, are sharp, but ground-based surveys offer another gift: sheer scale. The Vera C. Rubin Observatory, soon to begin operations in Chile, will scan the entire southern sky repeatedly, building a time-lapse of the cosmos. Its sensitivity to faint structures may reveal tidal streams, orphan stars, and intracluster light with unprecedented clarity. Meanwhile, giant ground-based telescopes, the extremely large telescope, the Giant Magellan Telescope, the 30-meter telescope, promise resolutions sharp enough to trace the faintest halos around galaxies. Their adaptive optic systems, correcting for atmospheric turbulence, will turn Earth itself into a platform for precision cosmology. Together, these surveys will expand the census of galaxies and measure the faint outskirts where forgotten light lingers. They will map the violence of collisions, the bridges of stars, the exiled populations scattered across clusters. Gravitational lensing, nature's telescope. But sometimes the universe lends a hand. Gravitational lensing. The bending of light by massive objects magnifies distant galaxies, revealing sources otherwise invisible. Strong lensing, where galaxies or clusters act as cosmic magnifying glasses, allows astronomers to study faint galaxies of the early universe in detail. Weak lensing, where distortions are subtle, allows for statistical mapping of dark matter across cosmic scales. Both are tools in the hunt for forgotten light. If the glow comes from faint galaxies, lensing may expose them. If it comes from exotic physics, lensing may reveal correlations between mass distributions and diffuse light unexplained by stars alone. In a sense, the cosmos itself provides the lens to study its own secrets, a trick worthy of cosmic irony, the noise and the truth. Yet with every new instrument, the core challenge remains: separating noise from truth. The cosmic microwave background was once nearly lost to terrestrial radio interference. The first exoplanets were nearly dismissed as noise in radial velocity curves. History reminds us that faint signals often masquerade as errors, and that errors sometimes masquerade as faint signals. The forgotten light sits precisely on this knife edge. Its very faintness makes it vulnerable to doubt, but its persistence across decades, instruments, and wavelengths makes dismissal increasingly untenable. The next decade may decide if Webb, Euclid, Roman, Rubin, and their successors converge on consistent measurements. Then forgotten light will stand not as anomaly, but as fact. If they diverge, then perhaps it will dissolve back into skepticism. For now, it hovers in between, half-measured, half-believed, fully tantalizing. A decade of decision. The coming years carry the weight of resolution. Webb will probe deeper into the cosmic dawn. Euclid will map the web of structure. Roman will expand the census of faint galaxies. Rubin will scan the sky for orphan stars and tidal streams. Together they will either reconcile the glow or amplify its defiance. If the glow is confirmed, then models of star formation, galactic evolution, and even dark matter may require rewriting. Forgotten light will no longer be forgotten, but foundational, a key to cosmic history. If, however, the glow dissolves under sharper scrutiny, if it proves to be dust, noise, or subtle error, then it will join the long list of mirages in astronomy mysteries that teased but vanished. Either way, the next decade holds the verdict, closing reflection. There is a quiet humor in all of this. Humanity builds telescopes the size of houses, launches them on rockets, unfolds them in the cold of space, all to chase the faintest possible light so dim it could be mistaken for a smudge, so elusive it hides behind dust and noise, and yet it is this very faintness that carries the secrets of creation. The forgotten light is both nuisance and revelation. It forces astronomers to squint harder, to subtract more carefully, to question more deeply. And in that struggle, science advances. The next decade may solve the riddle, or it may deepen it. But either way, the forgotten light has already served its purpose to remind us that the universe resists simplicity, that silence is never truly silent, and that even the darkness between galaxies is haunted by radiance. It may be resolved into data, or it may remain a haunting. But for now, it is both a glow at the edge of certainty, waiting for the eyes of tomorrow's machines. Philosophical reflection. Psychikschaft, emotional close. The forgotten light is more than a puzzle of astrophysics. It is a mirror, a metaphor cast across the heavens, a whisper of memory made visible. For in its faint glow lies a truth that transcends numbers and models. The universe remembers. Every photon is a memory. It is the record of a moment that once was the death of a star, the collision of galaxies, the ignition of the first fire. Though stars vanish, though galaxies dissolve, their light remains, scattered into the silence. To study forgotten light is to study the memory of the cosmos itself, a memory written not in books or stone, but in photons wandering endlessly through time. Memory and loss. Forgotten light is the radiance of loss. Stars torn from their homes, flung into the void, continue to shine. Their glow is faint, but it persists long after their parent galaxies have moved on. This light is orphaned, yet not extinguished. It drifts, carrying with it the story of exile. There is a sorrow in this, a quiet reminder that nothing remains. Untouched by impermanence, galaxies collide and scatter, stars are stripped away, whole epochs of creation pass into silence, and yet loss does not vanish. It leaves behind traces, faint but enduring. In every halo of intracluster light, the cosmos reveals that what is forgotten is never truly gone. The forgotten light is both elegy and testament. It is the universe's way of saying, even in ruin, radiance remains. Cosmic memory. If the forgotten light is real, if it cannot be erased by dust or instruments, then it suggests something profound. The universe does not forget. Every photon that escapes into the void continues its journey, unbroken, unaging, bearing the memory of its source. The night sky is not the present. It is a vast archive of the past. Each point of starlight is an echo from years, centuries, or billions of years ago. To look up is to see memory itself stitched into the dark. The forgotten light, spread diffusely across the sky, is memory writ larger, still the sum of what once was, the residue of history scattered between galaxies. Perhaps the universe is not a void, but a library of photons, each page a memory of something that once burned. And though most of these memories are unreadable to the human eye, they exist nonetheless, waiting for instruments, for curiosity, for recognition, human reflection. And what of us? Are we not in some sense also orphans in the dark, drifting through a cosmos that birthed us yet indifferent to our presence? We too carry memory, fragile, fleeting, prone to loss. But unlike photons, our memories fade with time, lost to silence unless they are shared. The forgotten light reminds us of our own impermanence. It shows us that memory can survive beyond its source, that the past continues even when the present has moved on. And yet it also confronts us with paradox. The photons, drift without destination. They were not emitted for us, not designed to be seen, and yet, in the act of seeing, we give them meaning, the paradox of light. This is the paradox, photons meant for no one shape human understanding. The forgotten light does not seek our eyes, and yet it reveals the deepest truths of the cosmos when caught by our instruments. Its journey is indifferent, its persistence without intention. But in observing it, humanity finds not only data, but reflection. It is a strange kinship. We, finite beings grasping at infinity, photons, infinite travelers, carrying memory without knowing. They are the remnants of stories the universe know. Longer tells, yet by studying them, we retell those stories anew. Perhaps that is the role of consciousness in a silent universe, to become the witness, to see what was never meant to be seen, to find meaning in the unmeant, eternity in silence. The forgotten light speaks also of eternity. Photons may scatter, weaken, redshift, but they do not die. They journey endlessly, silent messengers from a past that cannot be undone. In them lies the promise that nothing is ever truly lost, that everything leaves a trace, however faint. There is solace in this. Human lives are brief, fragile, vanishingly small compared to cosmic scales. But perhaps, like photons, something of us endures. Perhaps our words, our acts, our memories scatter outward, carried invisibly into futures we cannot imagine. In this way, forgotten light becomes a metaphor for human legacy. We too leave traces in silence. We too are fragments of memory drifting in the dark. The closing meditation, so the story of forgotten light, is not only a story of physics, but of meaning. It is about memory, loss, and eternity. It is about the paradox of light meant for no one, yet shaping the minds of those who see. It is about the universe's quiet reminder that even in exile, even in scattering, radiance endures. Perhaps the forgotten light is not truly forgotten. Perhaps it waits patient, silent, uncomplaining for us to notice, to build instruments vast enough, sensitive enough, persistent enough to catch its faint whisper. Perhaps it is not memory lost, but memory kept, waiting for recognition. And in that recognition we glimpse ourselves, for we too are the universe made luminous. We too are fragments of light consciousness born from stardust, reflecting on the very photons that made us. When the astronomer looks at the faint glow between galaxies, they are not only measuring photon, they are measuring memory itself. They are listening to the voice of the cosmos telling them nothing is ever fully gone. Not stars, not galaxies, not even us. And so the forgotten light closes its circle of meaning, not forgotten, not lost, simply waiting silently until we are ready to see.